Well, there's a few factors here that we are going to be dealing with that will keep this poor air quality around. Let's get right to the numbers right now. The South Bay will have the worst air quality over the next 24 hours. Another seventh spare the air day in effect for our Saturday forecast.
We've been talking about spare the air days and air pollution in the Bay Area, but it's really important that we know what air pollution is to begin with. Pollution in general is any undesirable change in the physical, chemical, or biological characteristics of our environment that can somehow impact the health of organisms. There are natural and man-made sources of air pollution. Natural sources of air pollution could include things like volcanoes, whereas man-made sources of air pollution could come from stationary places such as factories or houses burning wood, or mobile sources such as trucks or cars. When those air pollutants are initially go up into the troposphere or lower atmosphere, they're called primary pollutants. And those primary pollutants can react with other chemicals in our troposphere to create then what are called secondary pollutants. Both primary and secondary pollutants can have many different effects. There are many different types of air pollutants. One major one that you should already be familiar with are particulate matter. Particulate matter is solid or liquid droplets that are in our air that when we breathe them in, they can get trapped in different parts of our respiratory tissue. The EPA categorizes these as PM10, or those with a diameter of less than 10 micrometers, or PM 2.5, which is less than 2.5 micrometers. It's important to know that as the particulate matter is smaller, it can get deeper and deeper into your respiratory tissue. So these little air sacs right here are called alveoli, and that's where the gas exchange occurs for oxygen and CO2. If we have particulate matter clogging up those little air sacs, you have a hard time breathing. Here's two different lungs. The lung on the left is a normal human lung, and the lung on the right has been probably from someone who is a smoker or lived in an industrial city for a long period of time. And you can see just the black soot and all that particulate matter that's stuck in there. It's really devastating to have a lung on the right. It can lead to something called emphysema, which my grandmother had, and I can tell you it's really, really painful. Another major air pollutant in our troposphere is ozone. So ozone, when it's in the troposphere, can aggravate our respiratory tissue and cause things like asthma, can actually lead to heart disease, can damage plants, break down rubber and tires, fabrics, and even paints. A memory trick I have for you is that ozone is good up high. We need ozone in our stratosphere to help protect us from harmful ultraviolet radiation. But in our troposphere, in higher levels, it can cause illness. Another major air pollutant caused by the combustion of fuel are carbon oxides. So carbon monoxide has one oxygen. It's a toxic gas that can reduce the amount of oxygen that your red blood cells carry to the rest of your body. We also have carbon dioxide, which we're very familiar with in the troposphere. And when we burn fuel, that goes up into our troposphere. And not only is it considered an air pollutant, it can also lead to the greenhouse effect. A big category of air pollutants I want to discuss are, are nitrogen oxides. These are NO, and we call NOx because sometimes there's more or less oxygen atoms in this molecule. But this is what leads to that like brown smog. When nitrogen and oxygen react through combustion, we can get these nitrogen oxides, and they can act as greenhouse gases and trap the heat from the sun. They can actually help generate ozone later on. They can also create particulate matter, and they can lead to acid rain. Sulfur dioxides are also produced through the combustion of fuel. So whenever we're burning things, we can get all these air pollutants. What happens is we end up with sulfur and oxygen combining as reactants to create sulfur dioxide. And that sulfur dioxide, again, can become a secondary air pollutant, which is sulfuric acid. And that can cause acid rain, which we'll learn more about this week. The last category of major air pollutants I want to discuss are volatile organic compounds, or VOCs. The biggest example of this is methane, so think about cow farts here. Um, but they can also come from human sources, so when we have our landfills and trash is decomposing, that bacteria can emit lots of methane. That's another source. But other types of VOCs include industrial solvents. There's some nasty chemicals from traditional dry cleaners, gasolines, and plastics. There's two big types of smog that I want you to know about. The first one is called industrial smog. So when you're thinking back to the Industrial Revolution with factories pumping out lots and lots of smoke, this is what you should think about. And it's considered gray air smog, and it's usually a combination of particulate matter and small droplets of sulfuric acid. Most industrialized countries have a pretty good handle on industrial smog because we have different standards for factories. But what we see a lot of in most countries are what's called photochemical smog. So photochemical smog is a chemical reaction, and let's just review. In any kind of chemical reaction, we have reactants are on the left-hand side of this equation, and we have products are on the right-hand side of this equation. And in this reaction, it's called photochemical, so think photo, that's light, chemical, these are chemicals, and this is smog, so smoke plus fog. So in this reaction, we have volatile organic compounds plus those nitrogen oxides. Remember, these both come from man-made and natural sources, but man-made sources include things from combustion. So these combine with heat and sunlight to create a whole variety of things, including ozone and other secondary air pollutants. Photochemical smog is a mixture of air pollutants formed by the reaction of these under the influence of sunlight. So the more sunlight that there is and the more nitrogen oxides that there are, the more photochemical smog we get. So particularly in sunny places like LA and Mexico City, we end up with large amounts of photochemical smog. So here's Mexico City, and it has this thick layer of both fog and smoke as a result of the sunny climate mixed with lots of cars. So let's answer that question that many of you have. Why is it that in the Bay Area we have worse air quality in the wintertime than in the summertime? Well, in the summertime, usually we're able to have this convection current going, where as the sun's radiation hits the earth, that hot air rises, and with it, it brings all of our air pollution, and it's able to drift on with the wind to go to other locations. But in the wintertime, we get these things called temperature inversions, which is where things are flipped upside down. So in this situation, we have cold air, and we have all of this pollution is being generated by our communities. And we have a layer of warm air gets put on top of this. And sometimes we also have these high pressure zones where this cold air is pushing down on this layer of warm air. And so basically, our convection current is trapped, and we no longer are able to have our pollution escape and distribute all over the world. Instead, it gets stuck right on top of us. Air pollution is a big killer. Each year, air pollution prematurely kills about 3 million people. But in the US, the EPA estimates that annual deaths range from about 150,000 to 350,000. So we need to come up with some solutions to both decrease indoor, like you've seen in your surveys, there's lots of different types of indoor air pollution, and outdoor air pollution through decreasing the products from combustion. Thank you for watching this podcast.